2 of this study guide. 1 second. There we go. Nope. Jack is moving my camera. All right, sorry for the glare and sorry for Jack, my dog. But hopefully you'll understand it. Okay, part 2, we're going to find the dy dx. So that means we're going to do some implicit differentiation. Remember, every time you take a derivative of y, we're going to attach a dy dx. So the derivative of 2y would be 2, but since I took a derivative of a y term, I would attach dy dx. The derivative of x squared is 2x. Don't need to attach dy dx because that's already an x term. The derivative of minus y to the fourth would be minus 4y cubed dy dx. And the derivative of 5 is 0. We're going to keep the terms that have the dy dx on this side. And we are going to bring over the term that doesn't, so that'd be negative 2x. I'm going to factor out the dy dx. 2 minus 4y cubed equals negative 2x. And then I'm just going to divide by the quantity. 2 minus 4y cubed. And you could reduce this if you want to. I'll actually accept this as your final answer because you, again, if we were to actually find the dy dx, we would have an x and a y value. Now this one, when you have x's mixed with y's, you have to do a product rule. So I'm going to call this my first term and this my second term. So product rule says first times the derivative of the second, which would be 2y, since it was a derivative of y, attach dy dx, plus the second times the derivative of 4x squared, which is 8x. And that's the derivative of that. And now I'm going to take the derivative of minus 7x, which would just be minus 7, equals, and now I'm going to take the derivative of the right side, which would be 6y squared, since I took a derivative of y squared, or have a y, I have to add a dy dx. Now, I don't like the way this looks. We're going to clean this up. We're going to make this one monomial 8x squared y dy dx. We're going to make this 8xy squared, and then everything else can stay the same. Now, you want to get all your dy dx's on one side. So, and then everything else to the other side. It doesn't matter which way you go. Again, it's up to you. I'm probably going to just move these two to the right and then move the dy dx to the left. So 8x squared y dy dx minus 6y squared dy dx equals, and I'll probably add the 7 and then minus the 8xy squared. Factor out your dy dx. And then divide by that binomial right there. Oops. 8x squared y minus 6y squared. And again, you can leave that as your final answer. Fine with me. All right, related rates. So this one is about a spherical balloon is inflated with water at a rate of 20 inches cubed per minute. How fast is the radius of the balloon changing at the instant the radius is 5 inches? So you got this balloon and it's being inflated with water. So you need to know the radius and you need to know the formula for volume of a sphere, which is 4/3 pi r cubed. Now what I do is I just take a derivative of it right now with respect to time. So this is dv dt. 4/3 times 3 is 4 pi r squared. And then we need to take a derivative of r with respect to time. And now I got to go back up in here and read what I know. So I know that the spherical balloon is being inflated at a rate, that's words for derivative. Inflation at a rate, that's volume. So this is 20. equals 4 times pi. So then I should either know something about r, or I need to know the change in r. What's happening as the rate of the radius being changed. So let's see. How fast is the radius of the balloon changing at the instant the radius is 5? So we know radius is going to be 5. We're going to find dr dt. And so let me move this up here. That would be 20 divided by 5 times 2 is 25 times 4 is 100 pi. Oops. Which is your dr dt, and then you can reduce that to be 1 over 5 pi. If you do put this in the calculator, you can leave that, by the way, but if you put it in the calculator, make sure you put the entire bottom in parentheses, and you get 0.064. If you're talking about a radius, that would be inches per minute, the derivative per minute. All right, now for this one, which is a cone, the height of a right circular cone is increasing at a rate of 3 inches per minute. The radius of the cone is related to the height by r equals 2h. Find the rate of change of the volume when the height is 7. Again, for cones, you have to convert your radius to height or vice versa, and that's what they told us right here. So the formula for cone is 1/3 pi r squared h. Well, if I know that r is equal to 2h, then I can call this r right here 2h. I know that doesn't look like my drawing looks accurate, but that would be 2h. So what I'm going to do is I'm actually going to change this formula to be 2h squared times h. I'm just replacing what I know, what I was told here, that r is actually 2 h's. And I'm going to clean this up now. So this is 1/3 pi. 2h squared is 4h squared times another h. Or another way to write this, sorry, Mr. Jack got in the way, Jack. Another way to write this would be 4 times a third, or 4/3 pi. H squared times h is h cubed. And now I'm going to take the derivative of that. So the derivative with respect to time of volume is dv dt. 4/3 times the 3 is 4 pi. H now goes to squared. And since I'm taking a derivative of h, you have to attach dh dt. And now let's put the other information we know. The height of the right circular cone is increasing. The height is increasing. Height is increasing. That's derivative of a height. So I know that this is 3. The radius of the cone is related by r equals 2h. Find the rate of change of the volume. That's dv dt. Rate of the volume. That's derivative formula. When the height is 7. So put a 7 here. Pi and 4 stay the same. And so we're solving for dv dt. And this becomes 588 pi. Or again, if you put it in your calculator, 1,847.3 inches cubed a minute. I'll accept either. All right, and then what about some business? And I know I made a mistake here. This should be P of X. A company that manufactures toys calculates its profit to be 200x minus x squared over 2, where x is the number of toys produced in a week. If the production in one particular week is 50 toys and is increasing at a rate of 10 toys per week, find the rate at which the profit is changing, okay? So let's take a derivative of P. We would call it dp dt with respect to time. And then the derivative of 200x would be 200 dx dt. Remember, this right here is really 1/2 x squared. So when I take a derivative of 1/2 x squared, that would be minus 2 times a half is 1. X decreased by 1, so to the 1. And again, times dx dt. So now let's put in the information that we were told, okay? if the production one particular week is 50 toys, the production is 50 toys, and the production is increasing at a rate, find the rate at which the profit is changing. This is what we're finding, DPDT. That's profit changing right now. So one of these is dx dt, the other one is x. So if this is the one that says increasing at a rate of 10, that must be your dx dt. Which would then mean that x has to be 50 toys. So that would be about $1,500 of toys changing per week. Alrighty, last page is elasticity of demand. Let's write the equation at the top here so we can remember. Elasticity of demand is X times the derivative of price demand over the price demand. So the elasticity of demand, a company found that the demand for its product, d of x equals the square root of 16 minus x. Find the elasticity function. So what I would do here first is I would rewrite this as 16 minus x to the 1/2. I would take a derivative of that, which would be 1/2 16 minus x to the negative 1/2 times the chain of this, which is -1. And I would still clean that up. Obviously, this goes to the bottom, 16 minus x to the 1/2. -1 stays on top, and 2 also goes to the bottom. So this is actually a better formula right here for the derivative. Now let's find the elasticity. The elasticity function says, okay, take x, multiply it by what you just got over here, -1 over 2 times 16 minus x, 1/2, all over the original function, 16 minus x to the 1/2. Okay? Now, and actually, I'm already wrong. I forgot a negative here. The elasticity formula is -x. So what ends up happening here is this will become just this top, -x times -1 is positive x over 2 times 16 minus x to the 1/2. And if you're dividing by a fraction, remember you can do keep, change, flip. And what will end up happening is this will still stay on the bottom and this will move to the bottom. And if you have 16 minus x to the 1/2 move to the bottom, you would get 1/2 of it. So your final answer would be x over 2 times just one of these, 16. Oh, I'm so sorry. It's my dog. 16 minus x, but it would be to the power 1. This is the elasticity of demand. Okay. Being such a bad boy. Find the elasticity at a price of $9. So again, what do? Just plug in 9 into what you just found. So you got to be careful here because if you got that wrong, you're going to get this wrong. 9 over 2 times 16 minus 9 is about 0.643, which is obviously less than 1. Now you need to somehow write this on a note card. If you're less than 1, that's good. That means you're inelastic. You need to circle that. Which means that an increase in price would be an increase in revenue. And that's good. That's what we want. Okay, we want to be less than 1. This is good. This is great. This is inelastic. Well, what about at $3? Well, let's see. 3 over 2 times 16 minus 3 is 0.115. That's actually still good. That's still good. That's still inelastic. We don't want to be over 1. If we're over 1, we're elastic. Okay? And so again, that means an increase in price would be an increase in revenue. We're still doing good. If we had anything, 3, 9, we're good. Well, what would be that maximum price? Well, let's find out right here. Find the price X for which the revenue is maximized. So you take part A, and you set it equal to 1. And you can think of it as being over 1, and you crisscross, and you get x equals 2 times 16 minus x, or 32 minus 2x. 3x equals 32. 32 divided by 3, since we're talking about a price x, it would be $10.67. That's the max. So anything after $10.67, not good. That would be elastic. Okay? Hope this helps.